your day so far. But we are going to go ahead and get started with chapter 7. Okay. So in chapter 6, we looked at the bonding of elements. So what types of bonds do we have between our different types of elements? And then how do we name these compounds based on the elements that we have present? Okay. Chapter 7 is going to build off these formulas more in depth. Okay, we are going to look at how can we determine the formula of these compounds experimentally when we don't necessarily have a name provided to us. Okay, so like in chapter 6, how we found out our formula from our name, now we're going to find the formula or solve for the formula of a compound based off experimental data. Okay, so we're actually doing this in the lab. And we are going to get started today by looking at percent composition. Okay, so our goal for the day is that we will be able to calculate the percent composition of elements within a compound. So this word percent is probably pretty familiar with you guys from your math classes or in previous courses. So we know when we want to calculate a percent, what we typically do is we take our part divided by the whole and then multiply it by 100. Okay, so we are comparing one part of our sample with how much we have in total. Okay, so let's just look at a simple example. So let's say we have 25 M&Ms, big M&M fan, and 11 are blue. What percentage of M&Ms are blue? Remember, when we calculate our percent, we're going to do our part divided by our whole, and then multiply by 100. So here we are looking at blue M&Ms in particular. Those are the ones we are focusing on. So that is what we're going to say is our part. And then we're comparing that to our whole sample. So that whole is our total number of M&Ms. Okay. So when we go ahead and calculate to find our percent, we'll do what part of the sample is blue. So that 11 blue divided by our 25 M&Ms in total. And then, of course, multiply by 100 since we're working with percent. And we'll find out of the sample that 44% of our M&Ms are blue. Okay, and we would expect if we opened up another bag of M&Ms that we would have the same percentage. Okay, so we would expect that we'd have 44% of all of our M&Ms end up being blue. Okay. We are going to apply the same concept looking at chemical formulas. Okay, and that's what our percent composition is going to be. Talk about percent composition. We again are talking about the percentage by mass of each element in a compound. So we have a compound like, let's say H2O. Out of the total mass of water, the total mass, what mass comes from our hydrogen molecules? And what mass comes from our oxygen molecules? Okay, so remember, when we are looking at mass, we need to look at the periodic table. So when we want to calculate our percent composition, so again, when we're looking at water, we want to find what percentage of our total mass comes from just hydrogen. What we're going to do is we're going to follow the same formula we did for just normal percent. We're going to do part divided by the whole. But here the part, that's the specific element that we are looking at. So when we do parts divided by whole, our part is going to be the mass of our specific element. Okay, what mass is that element contributing? Okay. And then when we divide that by the whole, that's going to be the mass of our whole compound, or the total mass of our compound. So when we calculate these, we need to take into account how much each individual element weighs and how much of each element we have. And then since we're working with percent, we need to multiply this by 100. Okay. So when we're talking about percent composition, we're finding the percentage by mass of each element in a compound. How much does that individual element contribute to the overall mass of that compound? Let's say we want to find the percent composition of calcium hydroxide. So we want to find out how much of the total mass of calcium hydroxide comes from each individual element in that compound, okay? So our first step for these is always to find out what your formula is first. We need to figure out what elements are present, okay? So calcium hydroxide, you know calcium, as we see on the periodic table, and calcium is ionic, or is a metal, so this can be an ionic compound, and calcium typically forms a +2 charge. Hydroxide, this is one of our polyatomic ions, so we would need to check our polyatomic ion sheet. And we see that hydroxide is going to be OH, and then overall it has a -1 charge. So since we have a metal, we know it's ionic. We know hydroxide is a polyatomic ion, so we have to look at that periodic or that list of polyatomic ions. So here, since it is ionic, we need to balance our charges. If we have a +2 and a -1, in order to get those to balance out, we are going to need 2 of our -1 charges, or 2 hydroxides. So our formula for this compound is going to end up being CaOH2. Because again, we need 2 of those OH -1s in order to balance out our 1 Ca2+. Okay, so that's always our first step. Find your formula. Because now we know we have calcium, we have oxygen, and we have hydrogen present in that compound. Okay, so we want to find out what percent each one of these individual elements contributes to that overall mass of our compound here, of our compound. We know we're going to do the mass of our individual elements that we are focusing on divided by the total mass of the compound. So before we can find the percent composition for each one of these individual elements, we need to find the total mass of our compound. Or if we think back to chapter 3, that's going to be what we call our molar mass. Okay, so our molar mass is going to be our total mass of that calcium hydroxide. Okay, and that's going to be our whole when we calculate our percent. Okay, so remember, to find our molar mass, what we're going to do is we are going to look at our individual elements on the periodic table. So if we look at calcium, we're going to see we have this 40 at the bottom of calcium square. And that number on the bottom tells us our mass. Okay, so this tells us that's a mass of 40 that we're going to want to add when we're calculating our total mass. We only have 1 calcium, so we only have to add 41. And then to that, we need to add the masses of oxygen and hydrogen. But be careful. Notice how we have that little subscript 2. That's going to tell us that we have 2 OHs. So we have 2 oxygens and 2 hydroxides here. So we're going to need to multiply each of those individual masses by 2. Okay, because if we have 2 oxygens, and if we look at the periodic table, oxygen is going to have a mass of about 16. We want to do 2 times to account for both oxygens that are present in our formula. Same thing for hydrogen. Our formula has 2 hydrogens, so we want to do 2 times the molar mass of H, which is 1. Okay. When you're finding your total molar mass, look at the periodic table, find your individual masses, and then add them up. Just make sure you pay attention to how many of each individual element that you have present. Okay, so once you have it all written out, this just becomes an arithmetic problem that you can plug in your calculator. And we're going to find that calcium hydroxide has a total mass of 74 grams per mole, since we're looking at molar mass. So what we want to do is find out of that 74 grams, what percentage comes from calcium, oxygen, and hydrogen? Let's look at calcium first. Okay, you know when we calculate percent, again, we do part divided by whole. Here, since we're looking at calcium, we're going to look at just the mass of calcium as our part. So we said from the periodic table, calcium had a mass of 40. Okay, so that formula is calcium 40. Okay, and we're going to divide that by our whole mass. Okay, that's total. And we said our compound in total weighed 74 grams. Okay, And then we'll multiply that by 100 since we're working with percents. And we'll find out of the total mass, calcium contributes 54.05. Okay. So if we have a molecule of calcium hydroxide, 54% of that molecule is going to be calcium. Okay. Likewise, when we look at oxygen, here our part, that's going to be the mass of the element we're looking at. Here, that's oxygen. When we looked at the periodic table, we said oxygen had a mass of 16. So here, we would take our oxygen mass. Okay. So our oxygen atoms are contributing a total mass of 16 grams each, or 32 grams in total. Okay. And then, of course, we need to divide that by our whole mass, or the total mass. And since we're working on we multiply 100, and we found out of our total mass, oxygen contributes 43.24%. And that leaves us with just hydrogen. Same idea. To find our percent, we do part divided by whole, where the part is just the mass that hydrogen is contributing. And since we had two hydrogen atoms that are each contributing 1 gram, our mass from hydrogen is going to be a total of 2. Okay, and then we need to divide that by the total mass of our compound, of 74. We find that hydrogen contributes 2.71% for overall. And that makes sense because hydrogen is so light. It's not going to contribute a large amount to that overall. Okay, so here we found how much each element in calcium hydroxide contributes to that overall molecule or its overall mass. Okay? If we look at these, a good way to double check this is that whenever you're working with percent, your percent should always end up to 1. Okay, because we're looking at how the total mass is affected by each one of these elements. No more, no less. Okay. Okay, so let's say we have 100 grams of calcium hydroxide. Calcium hydroxide. We have 100 grams. We want to see how many grams of calcium are present. So we just found out, looking at calcium hydroxide, that calcium accounts for 54.05% of our overall mass. Okay, so that means if we have 100 grams calcium hydroxide, 54% of that is going to end up being calcium. So to find out what that would be, what we'd end up doing is we do 100 grams and a total mass of calcium hydroxide, and then multiply that by what percent of that is calcium. Okay. Just make sure you convert that percentage to a decimal. So 54.05 grams, to convert it to a decimal, we divide by 100, and we'd end up with 0.5405. So that means if of that 100 grams, 54% of that is calcium, we would end up with 54.05 grams. Okay. And we notice we have that nice number here because we're looking at 100 grams. We could follow that same process if we had 50 grams of calcium hydroxide, 20 grams of calcium hydroxide, however much we have in front of us. But no matter how much we actually have in front of us, your percent composition is always going to be the same. So whether we have 100 grams, 2 grams, 1,000 grams, our percent composition is always the same. Let's say we want to find what percent of nickel 2 oxide comes from nickel. Okay, so again, we're finding our percent composition, but we're really just focusing in on that nickel. So remember, a good first start for these is always write your formula. Okay, so again, we know it's an ionic compound because nickel is a metal. Nickel is a transition metal, but remember that Roman numeral 2 tells us the charge of that nickel ion. So that 2 tells us that this nickel has a charge of +2, and it's bonded with oxygen, and we know oxygen always forms a charge of -2. We're lucky here because our charge is already balanced, so we only need one nickel and one oxygen for our formula, which ends up being NiO. So what we want to do is, based on this formula, this NiO, we want to find what percent of that comes from nickel. Okay. So remember, when we're doing our percent composition, we're going to do the mass of our element divided by the total mass of the compound. So before we can find our percent composition, we need to find what the mass of nickel 2 oxide is. Okay. So again, that's going to be what we call our molar mass. And that's what we find by looking at the periodic table. So take the mass of nickel, and we only have one of them here. So I don't need to multiply it by anything, plus the mass of our oxygen. So when we look at the periodic table, we're going to see, what's going on here? That nickel, again, that number underneath, has a mass of 58.69, and oxygen, again, has a mass of 16. So when we want to find our total mass, we'll add the mass of our nickel, our 58.69, plus the mass of our oxygen, our 16. And when we add those together, we'll find that our total mass is 74.69. Okay. So we want to find, of that 74.69, what percentage comes from nickel. Okay, so what we'll do, we'll take the mass of our element, the mass of our nickel. What part is it contributing? Our 58.69. And then divide that by our total mass, which is 74.6. Okay. And when we do that, we'll find that nickel accounts for 78.58% of our total mass. Okay, so looking at nickel 2 oxide, 78% comes from just the nickel. Okay. If we wanted to, we could find the percentage of oxygen just by taking 100% minus the percent that comes from nickel, because we know percents always have to add up to 100. So that leaves us with 21.42% remaining that has to come from our oxygen. All right, so what we're going to do in our next problem is we are going to compare the percent that we got here using our molar masses to a experimental problem. Okay, so we found nickel 2 oxide is 78.58% nickel and 21.42% oxygen. So here we have an actual sample we have in the lab. Okay, so we have the sample that's made of 8.1 grams of nickel and 2.2 grams of oxygen. We want to find what percent of this compound is nickel. Okay, so remember, when we do percent, we're going to do our part, or the mass of just the nickel, divided by our whole, or the mass of our compound. This one is actually kind of nice and easy because they give us those masses experimentally. Here, we know what we have in front of us, so we don't need to go check the periodic table. Okay, so we know our mass of nickel is 8.1 grams. And to get the total mass of our compound, we want to add the mass of our nickel and the mass of our oxygen together. So 8.1 plus 2.2 to find out what our total mass of that compound is. And we'll find that our total mass here is 10.3 grams. Okay. And then since we're working percentage, we'll multiply by 100, and we'll find that this compound is 78.6% nickel. Okay. We should find that this matches up with the percentage that we found earlier. Okay. So we can see whenever we have nickel 2 oxide, we're going to have that same percentage. Okay, whether we're working with experimental data in the lab or we're looking at theoretical data on the periodic table. Okay. All right, guys. So let me know if you guys have any questions. Again, just main ideas for today. Look, when you're doing your percent composition, you're finding the percentage by mass of each element in a compound. So we're going to do the mass of our element, or just the mass that that part is contributing, dividing by the total mass or the whole of our compound, and then multiplying by 100. Again, to find your masses, you'll either be given them or you'll have to look at them on the periodic table. It's that number on the bottom. And then you'll also need to take into account how many of each element you have. Okay, because if you have two oxygens, you're going to have two oxygen atoms contributing mass to your compound. Okay, so pay attention as to how many elements of each you have. All right, have a wonderful day.